All right, our super consistent numbering of the examples continues on this slide. This one is just example, but we want to find the velocity of block A if 6 meters per second is the pulling velocity of the rope at B. So nothing too crazy here. I'm going to try and split screen us here so that we can show work and have the picture in our heads here. So here we go. We've got a nice and easy problem where if we're looking at the statics of this, right, we've got P, 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 no problem, right? So P goes all the way through. So if we're looking at block A, that means we're going to have two P's going up. So that's got to be two P's going down to block A. So block A is going up twice as slow as B is going down. Right? That's really all the work we have to show. Probably didn't need a whole paper for that. But our relationship is then that the velocity of A is the opposite direction, so we'll give it a negative sign of half of the velocity of B, right? And we got that because we could have said that, you know, the weight of A is, you know, twice what you have to pull with, 2P, right? Or P equals half of the weight of A, right? So that same relationship between A and B is all that we had to come up with, right? Point A moves twice as slow as point B, and it moves in the opposite direction. So that is it for that one. We could just say VA equals -1/2 times VB, where VB was going down 6 meters per second. So VA is going up 3 meters per second. Super easy on that one, right? In fact, so easy, we're going to combine it with this next one, which is the group problem solve. See if you can come up with this one. Slightly different, where now we have a rope going inwards. And let me blow this guy up for a minute. They want us to find the speed of block A at t equals 1 second. Well, now we have a motor with a time-dependent function for the speed, right? Which would make sense, right? It'd start kind of slow and get progressively faster is what it's looking like. So our plan, there's only one chord. This is going based off the way the book likes to solve these. Let's look at it as a statics problem and then do the inverse relationship. So right here we've got P that it's pulling in with the motor. Same P, same P, same P, all the way through. So right here we've got 3P pulling up and one cord pulling down. That must have 3P in it, right? Meaning whatever speed we pull with here, it is going to go 3 times as slow here. So if we want to write that as an equation, the velocity of some point, let's just call it the velocity of the motor, it is 3 times faster than the velocity A. Right? And it's a little weird because the velocity of the motor goes to the right. We could just call that positive. This would also be positive. So I'm not too concerned about that. Really, the relationship is this that we want to know, right? So if we want the speed of block A, it would be a third of the speed of the motor. So now we just need what the speed of the motor is, right? If the speed of the motor is this function, 5t raised to the 3/2 power in meters per second, plug in 1 second, and we've just got 5 times 1 raised to the 3/2. That would just be 5 meters per second, leading us to this same answer. Right? VA then is a third times 5 meters per second, which would be 1.66666, so just round it off to 1.67 meters per second going up. And that's it for that one. So the book makes a little bit of a bigger deal about these than they really need to. It's not super complex stuff. Um, you can you can solve those just using the inverse relationship that we found previously in our statics problems.